All right. I'm not doing today's daily. Just taking a break from that. Just got to work through my first 100. Merge sorted array. You are given two integers integer arrays nums1 and nums2 sorted in non-decreasing order. So non-decreasing order is, for those who are unfamiliar, it sounds weird, but it makes sense. It's clarifying that it's not necessarily increasing because increasing would be 1, 2, 3, 4. But this is not increasing if I do 1, 2, 2, 3, 4. Well, 1, 1, 2, 2, 3, 4. That's not increasing. It's just not decreasing. It's never going to be less. Okay, but it might be equal. So they have to specify that. All right, and two integers m and n representing the number of elements in nums1 and nums2 respectively, merge nums1 and nums2 into a single array in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Okay, so so the reason, so it's it's a little bit weird because it's giving us two numbers instead of telling us the lengths. Well, instead of just having us derive the lengths of each list, but that's because nums1 is going to have way extra space, but the actual numbers that we care about is only a part of that, and the others are filler zeros so that we can modify it in place. Let's bang this out really quick. What we're going to do is we're going to work our way backwards through this. All right, and the reason why we want to work our way backwards through it is because that way we're filling in the zeros, the extra space, rather than shifting everything forward. For example, if I had 1, 2, 3, 0, 0, 0, or no, actually, let's say that nums1 was 4, 5, 6, 0, 0, 0, and nums2 was 1, 2, 3. Okay? If I was to do this backwards, then that's simple because then I'm just setting nums1. I'm setting, I work my way backwards through nums1. And so I do something like I have 4, 5, probably set that to 0. And then I have 0, 0, 6. All right? Because I'd compare the two greatest values in that, and then I work my way backwards through that. So now I'm comparing 5. If I, well, 5 to 3 and so on. So you're working your way backwards and building the list from by getting the biggest value from both lists and stitching the larger one to the end of nums1. The reason why you would want to do this instead of going forward, intuitively you'd think, okay, well, build your way up by going from the smallest list to, well, by going from the smallest number to the biggest number, is because of how arrays work. I only have to change one number to do this. But if I was to edit nums1 to work my way up and, insert the 1 to be at the start, I now have to shift over all of those numbers. So it's not just a matter of changing the 1 to the 4 to a 1, because where does the 4 go? Well, you'd have to shift the 4 up 1, then you have to shift the 5 up 1, then you have to shift all the other numbers up 1, and just way too many operations per swap that you make. So working backwards is better. So what we're going to do is we're going to work our way backwards like this. Okay, we're going to have two pointers. Decrementing, yeah, is that the right word? From m and n. Okay, check if check which current pointer towards respective list is bigger, and then set that one to be the next largest. Okay? So as I said before, we're doing it decreasing because it requires way fewer swaps because you don't have to shift all the values in nums1 up. Rather, you're just building it downwards. Okay. And as for any concerns that, one thought I had was like, well, what if, you're replacing the zeros. You have like 4 or 5, 1, 2, 3, 0, 0, 0. Aren't you worried that at some point you're going to stop overwriting zeros and start overwriting the numbers that you care about? And the answer is no, that can't actually happen, because once you get to that point, then you're officially done, and those values would just be like, once you get rid of all the zeros, either the numbers earlier will be shifted up. So like if this is 6, then eventually the list is going to turn into like 1, 2, 2, 6. Or if it's 1, 2, 3, 0, 0, 0, and we work our way down, then that 3 is going to be where it's supposed to be. Well, I feel like I'm rambling. I'm not making any sense right now. But yeah, basically those numbers you're never going to overwrite any number, because it's either going to move out of the way before that becomes a problem, or it's going to be where it needs to be. Right? So, and it'll make sense once we write it. Okay, so we're going to say 2 pointers decrementing from m and n. So we're going to say I, j, k equals, and now remember the m and n is the length of the list, so we do need to account for the 0 index. So we're going to say I is equal to m minus 1, j is equal to n minus 1, and then we're going to have a total pointer that's going to sum up those two. So we're going to say m plus n minus 1, because that is the length, because remember, nums1 has m for the length of the numbers that matter, and then m plus n is the length of the nums1 plus the placeholder zeros. So we're going to have k, and k is going to we're going to decrement k every time. So basically, like, okay, if we have, I don't know, 1, 3, 5, 0, 0, 0, and we have 2, 4, 6. Okay, so for example, I is going to start at 5, j is going to start at 6, and then k is going to be this little 0 right here. Okay, so the first thing we say is, okay, which value is k now set to? Is it the one that's pointed towards by j, or the one that's pointed towards by I? It would be j. So now we set this to be 6. Okay, and we tick j down by 1. So now we're dealing with the 4. Okay, so now what's bigger, the 5 or the 4? The 5. And k has now been shifted down 1. So the 5, that gets turned into a 0. All right, and then the 4, and you see we're working through them. So we tick down the I or j depending on which value got put onto the end of the list, and we tick down k every time because we're working our way backwards through it. Okay, let's just program this. We'll get it done. I'm not making any sense right now. Okay, so we're gonna work our way backwards. So we're gonna do a little double pointer loop by using a while loop, so that we can check if either one has hit the end. Okay, now we're going to check which one's bigger. So we're going to say, okay, if nums1 I is greater than nums2 j, okay, then nums1 k equals nums1 I. Okay, so I'm not going to explain it anymore. I feel like you've got it by now. But yeah, so we have this pointer, this third pointer right here points to the value that we're currently setting, and then the other 2 pointers point to our current contenders for the next highest value, and we decrease them every time so that we don't repeat adding the same value. Okay, sounds good. Now we since we used up that value, now we decrease I by 1, and then the else statement is just the inverse of that. If it's not greater You know, we don't have to worry about the case of what if they're equal, because we just need to make it non-decreasing. We don't need to make it, well, so yeah, they can be equal, and we just pick one. It doesn't matter. We're going to say nums1k equals nums2j. Okay, and then regardless of what happens, we tick down, well, k by 1. Awesome. All right, so now once we've reached the end, we do still have one consideration to make. One sec. If j hit 0, because j is the pointer in nums2, and nums2 is the one that doesn't have the extra space. If j hit 0, then that means that we have ticked through all of the nums2 values and added them to the list, because that only happens when we add num2 to nums1. So we need to make sure that we have it covered in case nums1 hit the end. Because if nums1 hit the end, we're still not in the clear. Because, here's an example, we could have 4, 5, 6, 0, 0, 0, and nums2 could be 1, 2, 3. Okay? Then then nums1 gets turned into 4, 5, 6, 4, 5, 6, because all three of those numbers are bigger than 3, and we tick our way down. And so this current loop is saying, okay, well, we're done, because I eventually hit 0, or is now less than 0. But we're not in the clear because we still have to copy these over. So thankfully, since most of the work is done by this point, we can just say, okay, well, if we still have any values left in nums2, like if we haven't ticked to the end, then that means that all those values are lower than all the values that we've currently added. Okay, so we can just copy those and put it into the list. We're going to do it like this. Got it? All right, cool. That's it. Yeah, let's see. Let's run that. Cool. Yeah, so basically this is saying, okay, if j is equal to 0, well, if j is less than 0, then that means that we've gone through all of nums2. And if we've gone through all of nums2, then nums1 is fine where it is, because those numbers are already in the list. But if we've reached the end of nums1, of the nums1's values, we haven't necessarily copied over all of the nums2 values. So this is just copying over all of the remaining values from nums1 that are lower than all of the values that we've added so far. Yeah, that's it. Let's submit that. Awesome. And it does really well in runtime memory because it's working backwards and not forwards. Yes, I'm sorry. I wasn't on the top of my game today, but, you know, that's why I just did one. I didn't do the daily just because I wasn't really feeling it. And today's was complicated. It was like Dijkstra's algorithm, and you had to modify it. So, yeah. Thanks for watching. Really appreciate it. Let me know if how it can be better for you. Tomorrow, I'm sure it will be a little bit better. Yeah. Thanks for watching.